This video is to help you complete the data analysis for the lenses experiment. In the first question, you're asked to identify the type of magnifying glass that you have, or the type of lens that you have in the magnifying glass. By inspecting the shape of the glass, you can determine which of the given types your magnifying glass is. In the second part, please upload a picture of your optical bench by clicking on this space here. And in question 3, when you created your camera, please upload an image of the distance object focused on a screen. So, in the experiment with the camera, you are asked to measure the distance between the screen and the center of the magnifying glass. That is an estimate for the focal length of the lens. In my case, I got a result of 23 centimeters. Typically, when you go and buy glasses, the focal length of glasses is expressed in diopters, and that is the reciprocal, which means 1 over, the focal length of the lens in meters. So, to calculate the focal length in diopters, the first thing we will do is convert the focal length to meters. So, the focal length is actually 0.23 meters, because there are 100 centimeters in a meter. We will then take the reciprocal of this value, which is 1 divided by 0.23, and the answer that I got for that, just looking at my calculations, was 4.76 diopters for the magnifying glass that I had. In the next part, part 5, here we analyze the data gained through applying or through the data gained in the lens formula part of the experiment, where we're going to verify that this formula actually works. So what we have here, distance V is the distance between, let me just get that in focus. So this V here is the distance between the center of the lens and the focused image on the screen. U is the distance between the center of the screen and the object, which in our case was the flashlight. The sum of these would be 1 over the focal length. So let's see how we verify this. In my first experiment, the results I got for my first try was that U was 31.5 centimeters, V was 68.5. I calculated the reciprocal of 31.5. That's basically 1 over 31.5, and that's equal to 0.0317. Now I have to calculate 1 over V. That's 1 over 68.5, and that is equal to 0.015. According to this equation, if we add up these two quantities, we will get the reciprocal of the focal length. So when I add these two numbers together, 0.0317 to 0.015, I get 0.046. And if I take the reciprocal of that, which is going to equal 1 over 0.046, that gives me my focal length, and I measured that to be 21.6. For my second attempt, I got 67 for U and 33 for V. 1 over 67 is 0.149. 1 over 33 is 0.0303. If I add these two numbers together, I get 0.045, and the reciprocal of that is 22.1. Then my third attempt, I got the results 39.2 for U, 49.5 for V. 1 divided by 39.2 is equal to 0.0255. 1 divided by 49.5 is 0.0202. If I add these two quantities together, I get 0.046. And if I take the reciprocal, I get 21.6. So in my case, the results were very similar to the focal length obtained in the camera experiment, which was 23. So in the part 6 of this analysis, you can write your conclusion on the data that you obtained. And that's it for the data analysis.